Hi all, with this video I would like to explain how to find candidate keys and how to find super keys of a relation with a simpler method using set theory.
Consider a relation R of A, B, C with the functional dependencies say AB to C and C to AB. When you find AB closure, you will get A, B and C, which is all the attributes of a relation, and then it can be called super key of the relation. When you find C closure is C, A and B. It is also all the attributes of a relation and it is called super key of the relation. Now in this, AB is a minimal set and C also will be called minimal set. Then both are called candidate key of the relation. Now we have two candidate keys in a relation, that is both AB and C. If there are two candidate keys in a relation, the number of super keys can be calculated in the simple way, where if you consider AB as a candidate key, the remaining attributes of the relation are C. If you consider C is a candidate key, the remaining attributes are AB of a relation. According to the set theory, assuming this is set X, this is set Y, we have to find how many possible ways by using these two X and Y. The possible ways we have to find, like that is X union Y we have to find. That is cardinality of X union cardinality of Y is cardinality of X plus cardinality of Y plus minus cardinality of X intersection Y. Say cardinality of X. X contains one attribute. With the one attribute we can find two possible ways. One is pi, one is C. That is number of possible ways is 2 power 1. With AB, two attributes, we can find totally 2 power 2 possibilities. That is A, B, AB and pi. Totally 4 possibilities. Minus X intersection Y. The common attributes of X and Y is empty. So that number of attributes are 0. So the common number of possibilities are 2 power 0. That is total number of possibilities are 2 plus 4 minus 1, which is equals to 5 super keys. When we see in detail about what are the 5 super keys, say if we consider AB as a candidate key, we consider C as a non-key attribute. The possible sets with C are pi and C. If AB is concatenated with pi, you get AB is a super key. If AB with the C, we get ABC is a super key. So both are super keys. If you consider C as a candidate key, the candidate key with all the other attributes, possible set of attributes, is called super keys. Now if C is a candidate key, the possible set of attributes are AB. Now AB can appear in 4 combinations like pi, A, B and AB. That is C with pi C, C with A, AC, C with B, BC and AB with C, that is ABC. The total super keys are AB, ABC, C, AC, BC, where ABC is repeated. Total number is 5 super keys. Totally 5 super keys of this relation. Those are AB, ABC, C, AC, BC. These are 5 super keys of a relation. Now this is a simple way of finding the super keys of a relation using according to set theory, and this is a practically we can prove that these are the possible super keys of a relation. So I will give you one more example where, and simple example. A relation R contains some attributes A, B, C with functional dependencies A to B, B to C are the functional dependencies. When we find A closure, the attributes are A, B and C. With A we can get B, with B we can get C. Now it is containing all the attributes of a relation, then it is called super key. And when you find B closure, we get B and C. That is not all attributes of a relation, it is not a key. There is only one super key and that itself is minimal, is called candidate key of a relation. When A is a candidate key, the other attributes are both B and C. With B and C, the possible subsets are 4, like pi, B, C, BC. A with pi A with B AB, A with C AC, and A with BC ABC. There are totally 4 super keys. Say if A is a candidate key and B and C are called non-key attributes. If A is a key attribute, A is a key, B and C are called non-key attributes. The number of non-key attributes are 2, so the number of super keys are equals to the 2 power number of non-key attributes, which is also equals to 4 super keys. This is one simpler way of finding the number of super keys. So we'll discuss one more example. It is a simple example I will give you, where we consider relation R of A, B and C with the functional dependencies A to B, B to C and C to A. To find the candidate keys, we find A closure, that is A closure is A with the B, B and B with the C, C. 3 attributes, all attributes of a relation, we call it is super key. When you find B closure, it is B, C and A, all attributes of a relation, it is also super key. When you find A closure, C closure, if you find C closure, you will get C, C with A, and A with the B again, it is called super key of the relation. Now when we see all these, all are minimal set of attributes. We also called every super key here in this case. We call in this case here A, B, C, 3 candidate keys. If there are 3 candidate keys, the number of super keys are now to be calculated in this way. Say when A is a candidate key, we call B and C are non-key attributes. Say A is a candidate key. With BC, there are 4 possible ways. Like say in previously we discussed like pi, B, C and BC. A with pi A with B AB, A with C AC, A with BC ABC. 4. If we consider B as a candidate key, when B is a candidate key, the non-key attributes are A and C. Again with A and C we get 4 possibilities. Pi, A, C and AC. That is B, AB, CB and ABC. Again when we consider C as a candidate key, again we get 4 possibilities. Pi, A, B and AB. Totally C. Here A with the C AC, B with the C BC and AB with the C ABC. Now with A we got 4 possibilities, with B we got 4 possibilities, with C we got 4 possibilities. Now totally we count it 1, 2, 3, 4 and 5. This AB is repeated, 6 ABC is repeated, 7 AC is repeated, and this is BC is repeated, ABC is repeated. Totally we find 1, 2, 3, 4, 5, 6, 7. Now totally 7 super keys. Now these 7 super keys are A, AB, AC, ABC, B, BC and C. So totally 7 super keys. Now this can be found, the number of super keys can be found using set theory method. So totally 3 candidate keys we find, 3 candidate keys, that is A, B and C. If you consider A is a candidate key, the non-key attributes are B and C. So that we see in this case, according to set theory, A is a candidate key, then BC are non-key attributes. You take BC in one set. If you take B is a candidate key, AC are non-key attributes. You take AC in one set. If you take C as a candidate key, you consider AB as in one set. Totally 3 sets. Now we have to find the total possibilities using X union Y union Z. That is called, we call cardinality of X union Y union Z. That is, cardinality of X union Y union Z is cardinality of X. With X we have 2 attributes. We get 2 power 2 possibilities. Cardinality of Y, 2 attributes. We will get 2 power 2 possibilities. Plus cardinality of Z, 2 attributes. Again we will get 2 power 2 possibilities. Minus cardinality of X intersection Y. The common attribute is B, means one attribute is there, 2 power 1. Then cardinality of X intersection Z. Common attribute is C, one possibility is there. One attribute is there, 2 power 1 possibilities. Then between Y and Z. Common attribute is A, one attribute is there, so that 2 power 1 possibilities. Plus cardinality of X intersection Y intersection Z, all 3. Nothing is common, so that 2 power 0 possibilities. So 4 plus 4 plus 4. Totally 4 3 is 12 minus 2 minus 2 minus 2. 6 plus 2 power 0, 1. That is 12 minus 6, 6 plus 1, which is equals to 7 super keys. It is matching exactly the what we calculated by using the simple method. So that is matching with the set theory method. This is a way you can calculate the number of super keys of a relation. Please, if you like this video, please like me on my website, and please stay tuned for more videos in my website. That is, my website is Ramesh Database Guru.in. Okay, you can watch more videos in this website. Thank you.